Positiveness and negativeness is not made for vectors. It's made for scalars, right? You can say that magnitude can be positive or negative, but in our case, magnitude is always positive. These can be positive or negative, but this doesn't apply to magnitude. So if you say a vector is positive, it's nonsensical. Right? The same as saying color of Tuesday is red. It's the same kind of thing. So just magnitude and direction. When you want to specify a vector, you say, okay, it is this big and it is in this direction. That's all. Magnitude is a number with a positive value, not direction. And these are two numbers that can be positive or negative, right? So sometimes we write components in terms of magnitudes, because magnitude is always positive. If it is negative, negative comes in front of it. It becomes more clear. We're going to have examples for that. This AX and AY uniquely specify the vector. If you give these two numbers for a vector, you know what the vector is, right? It's a point in the xy plane. You draw a vector from the origin to that, that's the vector, right? So these two numbers uniquely specify the vector. Another way to specify a vector is by giving the magnitude and direction. For example, say if you have x and y, this vector, you say, okay, it's 5 meters and at this direction 30 degrees to the positive x-axis, right? This way also, you can identify the vector. This is called angle theta. This is called magnitude. So these two numbers, magnitude and angle, also specify the vector uniquely, right? So if you can identify a vector like this and the same vector like that, with x and y components, there should be a relationship between them and go from this representation to that representation and come back. So what is the relationship between magnitude direction and the components? You can also look at the components here. This the point here is AX and AY, so this point is AX, and this point on y-axis is AY. So if you look at this right triangle, you can see that cosine theta is adjacent over hypotenuse. Adjacent side has length of AX, divided by hypotenuse has a length of magnitude of A, and therefore AX becomes A cosine theta. And as long as theta is from positive x direction counterclockwise, no matter what value of theta, it always gives you the right answer for the component. Means that if you are, if theta is more than 90 degrees, cosine theta is negative, and it gives you AX as negative. And you know, remember that the magnitude of A is always positive. So if you multiply it by cosine theta, which is negative, it gives you a negative value. And if you increase for any value of theta, this always gives you the right component value as long as theta is from the positive direction of the x-axis counterclockwise. So theta from positive x-axis counterclockwise is called standard angle. I call it standard angle when it is from positive x direction counterclockwise. And in that case, AX is always magnitude of A times cosine theta. Similarly, y component, if this length of this is the same as that, so this is like magnitude of AY basically, absolute value of AY, and you have sine theta equals to AY opposite over adjacent A in that right triangle, and therefore AY is A sine theta. And this is also, as long as theta is standard, always gives you the ay with its sign, with its positive or negative, not this sign, positiveness or negativeness. For example, if theta is negative in clockwise direction, like negative 30 degrees, sine of negative 30 degrees is negative 0.5 times a, gives you ay as negative. And as long as you're from 0 to 180 degrees, the y component is positive. From 180 to 360, the y component is negative. Or from 0 to negative 180, ay will be negative. So these two work as long as you have a standard value for theta. Okay, this is when you have magnitude and direction, you want to find components. But if you have components, you want to find magnitude and direction. You do the opposite way. Suppose you have ax and ay. You know the magnitude is, from Pythagoras theorem, magnitude is square root of ax squared plus ay squared theta, because tangent of theta is opposite over adjacent, is ay over ax. The theta will be tan inverse of ay over ax. But this doesn't always give you the right answer. Who knows when this gives you the wrong answer?
Different quadrants.
Yes. And which quadrants? Let me give you some examples.
Oh yeah, because negative and positive would be messing up, right? Because you wouldn't know which one is the bottom, like if the bottom's negative or if the top is negative, like.
Yeah, that's right. If the top is negative and bottom is positive, it's the same as bottom is negative and top positive. So it doesn't make distinction between these two. And if you calculate tan inverse of anything on your calculator, it always gives you something between negative 90 degrees to positive 90 degrees. It never gives you anything more than 90 degrees, between 90 to 70. So suppose a vector A is given by magnitude of 5, but its direction is 30 degrees from negative x direction clockwise. What are the components? How do you find ax and ay? If you imagine this, you could draw a picture of that. This is x and y. X and y. This is 30 degrees from negative x direction this way, clockwise. Means that it is in this direction. And it has a length of 5. That's A. Right? And this angle is 30 degrees. So how do I find the component? Yeah?
5 cosine 150, 5 sine 150.
That's right. So theta, standard, is equal to 180 minus 30. So theta is 150. Then you can just use those equations. Ax is the magnitude of A cosine 150, and ay is magnitude A sine 150. Because now 150 is the standard angle. So ax is 5 cosine 150. What is that? Negative 4.33. And ay is
2.5.
2.5 positive, right? So these are the components. Now, suppose you know the components, you don't know, forget about what they were. Try to find magnitude and direction back from these components. Magnitude A is equal to square root of ax squared plus ay, we get 5 units. Okay, that's what we started with. So far, so good. But what about theta? Is tan inverse of ay over ax. Ay is 2.5 divided by negative 4.33. What does this give you?
Negative 30.
Negative 30 degrees. Is that the right Theta? No. It is actually this way. So this formula doesn't distinguish these two vectors. So in order to get the right value, you need to add 180 degrees, right? But when do we add 180, when don't we add 180? Sometimes you need to add, sometimes it gives you the right answer, sometimes it doesn't. When is it that it does give you the right answer? And when is it that you need to add 180?
You need to like figure out which quadrant you're in, which one you want to be.
Yeah, you can do that, but there's a simple way to find out. If the x component is negative, you add 180. Because you see, for all of these values that it gives you, the x component is positive. It gives you the wrong value if the x component is negative. So if the x component is negative, you add 180. So it's here, to complete this equation, say plus 180 if ax is negative. If ax is positive, just leave it as it is, right? So when you calculate, but remember, put the negative signs for the components in the formula. And then, if the x component is negative, add 180 degrees to whatever your calculator gives you. Does that make sense? So that's an algorithm. You can always get the right answer if you do that. All right? All right, let me say vector B. Now I call it different, x and y. Vector B has a magnitude of b, and it's at 30 degrees to positive y direction clockwise. What are the components of b in terms of the magnitude? What is bx? What is by? Yes?
For bx, it would be b cosine 60, and then
That's right.
b sine 60.
Yeah, so you use the standard angle, which is this one, is 60 from positive x direction, would be 60 degrees. And then we have the formula, bx will be cosine of that angle, 60 degrees, or the y component will be b sine 60. Yes, this is very good. But another way is to write these in terms of this 30-degree angle that you have. If sometimes you don't want to convert to standard angle, sometimes it's easier to just write in terms of those. In order to do that, this is using standard angle, which is 60 degrees. But if you want to write in terms of the angle that's given in the problem, you don't want to convert to a standard angle, because this is non-standard angle. You can do it another way. We can look at this right triangle and see that the y component of B is adjacent to the 30-degree angle. And then say that, okay, cosine of 30 degrees is the y component, by, over the magnitude of B, which is hypotenuse. Therefore, by is equal to B cosine 30 degrees. Here was by equal to B sine 60. Here is by equal to B cosine 30. But it happens that cosine 30 and sine 60 are the same thing. Right? And then you say that, again, this is the x component, and that's opposite of 30 degrees. So you say sine of 30 degrees is equal to bx over b, and bx becomes b sine 30 degrees. And it happens that cosine 60 and sine 30 are the same, so you get the same answer. But how to memorize this? if you want to do it this way. In order to memorize that, you can say, okay, look at that angle and the vector and the components. The component that is always adjacent to that angle comes with cosine. Magnitude times cosine. The component that comes not adjacent to that angle, which is this component, is not adjacent to the angle, comes with sine. And then sometimes this doesn't give you the right sign for the component. But if one of these fall in the opposite direction of the axis, you put a negative sign by hand. Because this is not standard angle, it doesn't automatically give you the correct sign. Right? Okay, let's try something else. Vector C, that is 20 degrees from y direction counterclockwise. It's vector C. And it has magnitude C. What are the components? First, let's use the standard angle. Are you using standard angle?
Yeah.
Yes?
Yeah, it will be C cosine 120, or 110.
Yeah, 110, yes. 90 degrees plus 20 is 110. So the angle, theta for C, is 110 degrees. So if they say, for the x component, just close your eyes and say magnitude of C times cosine of 110 degrees. That's correct. And Cy, you just say C sine 110. And it happens that this becomes negative. So it has the x component as negative. And this becomes positive, and you expect it to be positive. Right? This is using standard angle. Always x component comes with cosine, y component comes with sine, and everything is fine. If you use non-standard angle, you want to write in terms of that 20 degrees that is given. Then you look at the y component or x component is not adjacent to the 20 degrees. So you say Cx is equal to, is not adjacent, it comes with sine. So magnitude C times sine 20. But it falls in the negative direction. I put a negative sign by hand. And Cy comes with cosine because it is adjacent. The y component is adjacent to the 20 degrees that I have is cosine 20 degrees. And because it is in the positive y direction, I don't put a negative sign. Or I put a positive sign to emphasize. And if you calculate this and calculate that, they are the same thing. If you calculate cosine of 110 and calculate negative sine 20, they are the same numbers. Right. This is using a non-standard angle. For non-standard angle, if it is adjacent, use cosine. Not adjacent, use sine. But insert a negative sign if that component is negative. If you look at it in opposite direction of the axis, it becomes negative. Another example, let's say vector D is at 25 degrees here. Dx, magnitude D, cosine 155, and y component, magnitude D, and sine 155. Always correct. But if you want to use the 25 degrees, what do?
Negative D sine of
Dx. Dx will be with cosine or sine?
sine.
No, adjacent to 25.
Yeah.
Yeah, adjacent to 25, it comes with cosine. It says D cosine 25 degrees, but it is in the negative direction. This x is this way. It's in the negative x direction. You put a negative sign in front of it. And dy, it comes with, is not adjacent. Dy is this way. It's not adjacent to 25 degrees. It comes with sine. And because it falls in the positive y direction, we keep it positive. Does it make sense? one more. Let's say E vector is in this direction, with this being alpha. Okay? Now, I didn't put a number, I just put alpha. This is E vector. And this is our x-axis, this is our y-axis. What is EX?
I think it's E cosine of 270 minus alpha.
Yes, E cosine is, we use a standard angle, E cosine 270 degrees minus alpha. That automatically gives you the right answer. And EY, sine of 270 minus alpha. But if you want to use alpha, what do you do? Instead of 270 minus alpha, we want to write in terms of alpha. What do we do? Yes?
For e to the x would be e sine alpha.
EX, yeah, EX is not adjacent. This is EX, right?
Oh,
Not adjacent to alpha, you use sine. E sine alpha, but is it positive or negative?
Negative.
Negative, so you put negative sign. And EY, it is adjacent, you see? Adjacent to alpha, so you use cosine. Is it negative or positive? Y component is negative, you use negative sign. So for non-standard angle, it is easier sometimes to do it because you write it in terms of the angle that's given in the problem. But you have to be careful whether to use sine or cosine, or whether to use positive or negative. You have to check to see how things work. If the component is in the adjacent side of the angle, you use cosine. If it is not adjacent, you use sine. And look at the coordinate axis. If the component is in the opposite of the coordinate axis, you put a negative sign by hand. In this case, both of them are. Right? You're going to use this a lot, especially about Newton's law.